B, C, D, E, and F.
A for architect of project, Tapela Sishoka, project manager.
B for building innovations and mitigations, the engineer Rotondora Mlumisi.
C for connecting with communities, community liaison Amparisa Wombad.
And D, driving decisions using driven data, Kolufelo Manini, the scientist.
E for ensuring environmental health by the environmental officer Nolita Valega.
And F for facilitating financial sustainability, the CFO Itepo Madroha.
And we are the Soundcloud team. Now, ladies and gentlemen, we're not just some regular team. We are the team that the National Department of Water and Sanitation chose to bring innovative and creative careers and solutions for the very stressing impact of water hyacinths on the Harties Dam. Now, to better your understanding, we have to first base it on the root of the problem, which is the invasive species. Invasive species are organisms that do not originate from a particular area. They outcompete native organisms for resources and cause disruption in ecosystems. They harm our environment. Now, the water hyacinths are natives in South America, but here in South Africa, they act as very hard and harsh invasive species. The fast-growing invasive species aquatic plant cover large areas, degrading water quality and harming aquatic life. The purpose of our presentation is to assess the impact of water hyacinths on the quality of the Harties Dam and propose realistic and sustainable solutions to improve water quality and protect the dam's ecosystem. Now, according to the Harties State Environmental Assessment of 2006, the Harties is located inside the Crocodile River. The dam is fed by the Mahalis and the Crocodile River. The main use of the dam is irrigation, recreational use, and domestic use. Areas directly around the dam, such as the Shum, Mansville, Melody, and Ifafi, utilize the dam by doing simple things as domestic use.
Now, as the environmental officer, I'd like to begin by bringing a brief background on the issue we are tackling, the impact of water hyacinth on the Harties Dam. Now, this invasive plant spreads rapidly because of high nutrient levels in the water, mainly from agricultural industries using fertilizers that wash into the river, feeding the dam. Now, another major factor is informal settlements with poor sanitation system pipes flowing into the river, such as Crocodile River and Mahalis River, to the dam. Well then, informal settlements during rainfall, dirty water and waste from roads mixed with industrial oils are washed into the Crocodile River, adding more pollution that further flows into the Harties Dam. Now, this adds huge amounts of nutrients into the dam, like nitrogen and phosphorus, which act like fertilizers for water hyacinth. Think of it like this. The dam becomes a giant plant pot full of free nutrients. And that's not all. On top of that, several wastewater treatment plants, including the biggest of them all, Northern West, discharge treated and sometimes partially treated water into the Crocodile and Mahalis River, which flows directly into the dam. As you can see into this picture, there is a wastewater treatment plant near the dam. So the wastewater treatment plant releases effluent into the nearest river that flows directly to the dam. Now, you might be wondering, what happens when our own waste ends up feeding an invasive plant? We don't just have policies on paper. South Africa has strong laws that link directly to controlling pollution and protecting our water bodies. Now, these laws help guide how we manage problems like the water hyacinth in the Harties Dam. Now, our first law is the Water Services Act of 1997. Now, this law ensures clean water supply and proper wastewater management. When sewage or dirty water from settlements and treatment plants flow into rivers, it breaks the law's goal to keep water sources unpolluted. Now, let's go to our second law, the National Environmental Management Biodiversity Act of 2004. Now, this law focuses on protecting biodiversity and controlling invasive species like water hyacinth that harm local ecosystems. Now, our final law, the National Water Act of 1998. Now, this act protects and manages all water resources in a sustainable way. Now, it reminds us that pollution from agriculture and poor sanitation systems must be controlled to stop nutrient buildup that feeds the water hyacinth. Now, let's take the moment to look at our findings. From our research, we observed that large amounts of water hyacinth are covering the dam surface, reducing oxygen levels and leading to fish deaths and loss of aquatic biodiversity. We also found that excessive nutrients are entering the dam through the surrounding rivers such as the Crocodile River and the Machalis River, from wastewater treatment works, agricultural runoff, and both formal and informal settlements. Now these nutrients are what makes the water hyacinth spread so quickly. Finally, we noticed that the dam's recreational and economic activities are being affected. Now, dam surfaces are blocked and the water quality is becoming more worse even for the lives of people, plants, and animals. Now then, it's clear that pollution control and nutrient management are keys to restoring our beloved Harties dam.
Now, ladies and gentlemen, I'll be defining what is an environmental risk assessment. It is basically a systemic process used to evaluate the probability and severity of environmental impacts caused by human activities. It is very important because it helps us to identify and assess hazards, to develop effective solutions, and to even protect health and safety. How we calculated it is by multiplying likelihood with severity. You might be wondering what exactly is likelihood and severity. Severity, it is basically the impact that an incident will have on the economy, the societies, as well as environment. And likelihood, it is basically the probability or possibility of that incident having to take place. Now, how we measure it, the first one, please move back to the slide. The first one, for severity, we measure it with a scale of 1 to 5. The first one being insignificant and the last one being catastrophic. And the same with likelihood, we measure it from 1 to 5. The first one being rare and the first one being almost certain. Now, moving on. Now, we classify all these risks into 3 categories. The first one being low risk, which is between 1 to 16, moderate risk, which is 7 to 14, and high risk, which is 15 to 25. These levels help us to determine which risks should be prioritized in vegetating. Now, based on the findings we received from the dam, we were able to note down all the risks that we could possibly find in the dam. Firstly, the water hyacinth could lead to loss of aquatic life, and the possibility of that happening, it is very likely, and the consequences of that, it is catastrophic. Thus, we have classified it as high risk. Moving on to eutrophication, the possibility of that happening as well, it is very likely, and the consequences, it's catastrophic as it will affect life, and aquatic life, and we classified it under high risk, as well as decreased water quality. The likelihood of it being bad, it is very likely, and the consequences will be catastrophic as they will affect the health of people, and thus we have classified it under high risk. And the possibility of reduced vocational use, it will be likely as well, and the consequences will be very serious as it will affect the economy of the country, the revenue of the country, and thus we have classified it under high risk. In terms of health risk, they will be very moderate depending on how many people actually go to the dam, as water hyacinth might attract mosquitoes. So but if people do get bitten by mosquitoes, they might get malaria, and thus we have classified that as under the consequence as catastrophic, and thus we have classified it as high risk. And lastly but not least, the water hyacinth can lead to increased water treatment costs, and the likelihood or the possibility of that happening is very likely, as the water hyacinth might get trapped in pumps as well as pipes as well, and that will lead to a catastrophic result, as now water will not be treated efficiently, and thus we have classified it under high risk.
Ladies and gentlemen, here are the assessed identified risks, mitigation measures, and explanations for the mitigations and innovation. Firstly, we have loss of native fish. We suggest that biological control of weevils and plant harpers shall be conducted. These insects reduce hyacinth biomass by improving oxygen levels for aquatic life and keeping the fish alive. Now, as you can see, the timeline for this mitigation takes about 6 to 12 months. With decreased water quality and eutrophication, we will upgrade sewage pipelines or uptakes, in a nutshell, nutrient load management. By improving phosphate and nitrogen inflows, limiting the food source for water hyacinth, and improving water quality simultaneously. As you can see, the timeline, it is ongoing. It is an ongoing implementation. For reduced recreational use, removal of ice and mud mechanically near recreational zones, harvesters will clear waterways for boats, and fishing will be done at 100 years port depth. A common solution for the first three identified risks is to increase wastewater treatment by combining biological and mechanical control. The control reduces the need for costly reactive treatment because biological controls are most effective and they are definitely long-term. Not forgetting about tourism and revenue, community education and engagement in order to encourage early removal and ongoing monitoring, which helps prevent large infestations affecting the tourism around the area. So ladies and gentlemen, to speed up the process, people around the area can use the water hyacinth as compost or animal feed. Water hyacinth can be used as a very nutritious feed, especially for agriculture. So ladies and gentlemen, we hope that you hear us and hear us well. We will engage with stakeholders and people around the community.
Now, ladies and gentlemen, as the community legion, my role is to bridge the gap between technical solutions and the people that are mostly affected by the water hyacinth crisis at Hyder Port Dam. The invasion doesn't just affect the water quality, it creates tension between communities, recreational users and businesses who are competing for access to the dam. Now, my job is to turn that conflict into collaboration. How? By bringing grassroots voices into decision making and ensuring that their concerns shape the solutions. By creating space for trust and shared ownership. Through engagement platforms such as C20, which represents civil society, and B20, which represents businesses, we can form public-private partnerships that combine community insight with innovation and investment. This partnership approach doesn't just tackle the hyacinth, it addresses the root causes, restores access, and transforms a source of conflict into an opportunity for collective action.
Ladies and gentlemen, regarding the financial aspect of managing the invasive Harpagiersport issue of the water hyacinth, we've outlined the budget estimate for a 3-year program. For biological control through insect rearing and release programs, the costs include 500,000 rands, which we are planning on getting from the Department of Water and Sanitation, 1,200,000 rands for mechanical removal equipment, including purchase and operation of harvesters, which we intend on getting from the Department of Water and Sanitation as well, 5 million rands for the sewage treatment upgrades in partnership with municipalities, which we plan on getting from the National Treasury, 250,000 rands for community education programs covering workshops, materials, and monitoring, which we will get from the revenue we will obtain from selling the harvested hyacinth plants to farmers, which they will use as fertilizers. And 800,000 rands for repairing buffers restoration, including planting and maintenance, which we intend on getting from the Department of Water and Sanitation. In total, the estimated cost for this 3-year program is 7,750,000. In conclusion, the invasive water plant crisis at the Harpagiersport Dam threatens water quality, aquatic life, and local communities. Through enforcing environmental laws and using a realistic, integrated approach, combining biological control, mechanical removal, pollution reduction, and community support, the problem can be managed effectively. This will improve the dam's ecological balance, safeguard public health, and restore economic benefits for the region. Ladies and gentlemen, these are the sources that we use. And finally,
We plan,
we build,
we connect,
we research,
we sustain,
and we facilitate financial sustainability.
together
We eliminate water hyacinths.